Dr. Sivabalan, Professor and Head, Department of Naval Architecture, Ahmed University. So today we are going to discuss about the topic of unstable equilibrium. So there are three different types of equilibrium. One is the stable equilibrium, and another one is the unstable equilibrium, and another one is the neutral equilibrium. So depends on the GM value. So this stable, the vessel may be in a stable, or the vessel may be in unstable, or it may be in the neutral equilibrium. So today we are going to discuss about the unstable equilibrium. So before getting into the topic, so first we will discuss about the basic, what is required to understand the unstable equilibrium. So first one is we should have the clear idea about the center of gravity of the vessel. So what is center of gravity? Center of gravity, we have, the human body have its own center of gravity. So until what position we will be in a balanced mode, means if our center of gravity fall in between our legs, means we will be in a stable position. Suppose we are traveling in a vehicle while during the time of the turning, so our center of gravity position may be fall outside of the body. Then what will happen? We may feel uncomfort or unbalance. So that is the effect of center of gravity. Center of gravity plays an important role for an object, particularly our vessel is concerned. The center of gravity plays an important role. It should be all the time below, how much it's possible, it should be below in the lowest position. So basically the center of gravity is the weight, the total weight of the vessel, where it is acting, through which point is acting, that is called the center of gravity. So the total weight, told about the total weight of the vessel is divided into two. One is the light ship weight of the vessel and another one is the dead weight item of the vessel. All together, the light ship weight items are constant one, like steel weight, machinery weight and outfit. It will be same for a vessel for a throughout lifetime of the vessel. And the dead weight items, all the dead weight items are what you can say, consumables. So basically cargo, fuel oil, diesel oil, lube oil, etc. So these are consumable. So altogether we can call it as a total weight. Where the total weight is acting, the vessel, which point, that point is called the center of gravity of the vessel. So how we can keep the position of we can manage the center of gravity of the vessel, whether we can raise the center of gravity of the vessel from keel or we can lower the center of gravity of the vessel. So that is the reason we provide all the tanks, particularly crude oil, lube oil tank, fuel oil, the freshwater, etc. We used to keep it at the lower level of the vessel. So then loading also plays an important role, how we are loading the cargo. So where we are keeping the maximum weight cargo. Suppose you are keeping the maximum weight cargo at above the deck, then your center of gravity move towards the deck. If you are keeping the cargo below the continuous deck or in the level of the tank top, then your center of gravity position will come down. So all the time, the better thing is we have to keep the center of gravity position as much as possible at the lower level. That is very safe for our vessel. So this is about the center of gravity of the vessel. Then another important factor we should know that is the meta center of the vessel. So the meta center related with our buoyancy. What is buoyancy? The reason for the body which is float on the water medium, that is because of the buoyancy force. It is providing the support. It is providing the vertical support to the floating body. So because of that, our vessel is floating on the water. Okay, so it is acting all the time. It will acting towards the upward direction. The gravity force acting towards the downward direction, or buoyancy force acting towards the upward direction. So most probably it will be at the center line of the vessel. The line of action of the buoyancy force will at the center line of the vessel. So due to the external force, it may be shifted either the port side or it may be shifted to the starboard side of the vessel. So if it is shifted to port side or starboard side, then the line of action also move. Where the line of action, shifted line of action intersecting the initial line of action, that point is called as meta center of the vessel. This buoyancy force or the total buoyancy force that has to match with the weight force of the vessel. Weight force has to match with the buoyancy force of the vessel. Then only the vessel will in the floating condition. It will float, it will be in a free floating condition. Now you are clear about the meta center. It is the intersection of the line of action of the buoyancy forces. It is now the meta center is clear. Now we move on to the metacentric height. We defined the center of gravity. we have defined the meta-center. So the GM is the vertical height between the center of gravity to the meta-center. It is the vertical height between the center of gravity to the meta-center. So this vertical height plays an important role to the vessel, may be in a stable condition, the vessel may be in an unstable condition, or the vessel may be in the neutral condition. This plays an important role. Initial metacentric height. It is very, very important for a vessel. Stability is concerned. So the G plays an important role, and also the M also plays an important role. Basically, the metacentric height plays an important role for a vessel. So now the unstable equilibrium, when the vessel reach the unstable equilibrium, the center of gravity, suppose the object, our vessel is in a free floating condition, it is subjected to external force. For example, the wave force or the wind force, these are the external force which may act on the vessel. Due to this external force, the vessel may be heeled to a certain angle. Further, if it is heeled, then it is called as unstable equilibrium. The vessel may be in the unstable equilibrium. When it is heeled, further keep on heel, when it will happen means the vessel may be in the negative G. Okay, the vessel may be in the negative metacentric height. G is located above the metacenter. There is a chance of G may be located above the metacenter. It should not be happen. If G is located above the metacenter, that is called as negative GM. This condition is called as vessel is in the unstable condition. Here also there is a moment will be created. That moment will not support the vessel to back to its original position. As per this diagram, the green color is the buoyancy force. This is acting vertically upward direction. And the red color one is the total weight force. It is acting towards the downward direction. It is through the center of gravity. We are loaded the cargoes are loaded in the vessel. So due to the cargo loading, the G position lies above the metacenter. So what will happen? So now that is explained as a couple. One couple with the two forces. Okay, one is the buoyancy force and another one is our weight force. This form a couple. This couple is rotate the vessel in the clockwise direction. Already the vessel is heeled towards the clockwise direction. The couple forces further, it will heel the vessel towards the clockwise direction. It will heel the vessel furthermore. So what will happen? Already the vessel heeled to a clockwise direction. Again the couple supporting the vessel to heel further in the clockwise direction. Okay, the total heel angle is more. What will happen? The vessel will capsize. Okay, so this is a capsizing lever. This G set is the capsizing lever here. This capsizing lever support to capsize the vessel. So this is because of the unstable condition of the vessel. So our G is located above the metacenter point. The vessel will reach the unstable condition. This is the unstable equilibrium. Now we'll move on to the correcting the unstable equilibrium to the stable equilibrium. We should not keep the vessel in the unstable condition. Metacentric height should be the positive one. So what we can do, what corrective action we can do? The weight already there on the vessel. Suppose we are in the case of a container vessel. The container vessel, we used to keep the cargo over the continuous deck also. What we can do, the maximum weight cargo, the container vessel, the three types of container may be there. If the container may be fully loaded, container may be a partially loaded container, may be an empty container also there in the vessel. What we can do, the fully loaded container, we can keep it at the bottom of the vessel, means in the tank top level. Okay, as much we can lower the fully loaded container. So the lowest level. Then what will happen means our center of gravity position will come down. Then the weight may be below whatever the weight which is there, that we can load below the center of gravity of the vessel, that we can do. Then if suppose free surface effect is there, okay, so that we can remove, or what we can say, we can add some water at the bottom in the ballast tank. With that can lower the weight. With that we can lower the position of the center of gravity towards the tank top level. With that we can get the positive metacentric height So with that, we can convert the vessel or bring back the vessel from the unstable equilibrium condition to the stable equilibrium condition. So these are the things we can do. With that, we can make the vessel from unstable condition to the stable condition. Thank you.